features associated to them. So imagine you're sitting at a restaurant. You go and you sit at a table. How do you get food? Well, you ask a waiter, and the waiter is going to take your order and bring it to the kitchen. Once the kitchen is done preparing your food, the waiter will bring back your food to the table. This is very, very similar to how an API works. We're going to be using this analogy to explain the different parts of an API. So keep this in mind while we go through this video. A technical definition of an API. So an API is an application programming interface. It exposes a service and developers write programs to consume it. So if we go back and we think of the actions or the apps in the past video, we might take the example of Google Sheets. So Google Sheets has an API, and in the API we have different services. So one of these services might be get all of the data in a specific sheet. And so the Google Sheets API exposes the service that allows you to read data in the sheet. Developers write programs to consume it. So using n8n, we're going to be able to consume the Google Sheets API using the different services, for example, updating rows or getting data in a sheet. Using this metaphor, we can see that the waiter is what's going to be called the interface, and the application is going to be the kitchen. So in this case, the application might be the Google Sheets, and then we're going to be using the interface to interact with the application. Why do we need this interface to interact with the application? Well, it allows us to abstract the complexity. Imagine if every time you went to a restaurant, instead of just sitting down and ordering food, you had to go to the kitchen and explain your order, wait for it to be done, and then take your food back to your table. This would be much more complicated than just asking the waiter for your food. The same thing goes for applications. If every time you wanted to read data in a Google Sheet, you had to go to Google servers, find your specific sheet, and then read the data from it, that would be much more complicated than just using the API, which gives you a very abstract but easy way to access the data from the application. So how does an API work? It uses what's called documentation. So documentation explains how the application programming interface or API works. And using the restaurant analogy, it in this case would be the menu. So a little bit of terminology. We send a request through the interface to the application, and the application uses the interface to send a response. We also have the client-server notions. In this case, you would be the client, and the application and the interface would be the server. So keep these in mind when you see these terms. When using APIs, we have, as mentioned earlier, requests and response. So we're going to break down the different components of a request and the different components of a response. Starting with a request. There are four main components to an HTTP request. In these videos, we're only going to be talking about HTTP requests. There are different frameworks to make API requests, such as GraphQL, but most of the APIs that you're going to use are going to use the HTTP framework. Everything that we're going to talk about today is mirrored in the HTTP request node. The HTTP request node allows you to make HTTP requests in n8n and receive the responses. This is going to be very useful when building automations that need to use specific APIs. There are four components to an HTTP request. There is the URL, the method, the header, and the body. Let's look at each one of them. The URL is the unique location for a resource on the web. This can be a page, an image, a PDF, or some data. Here we have an example of a URL. You can see a scheme, a host, a port, a path, and some query parameters. The scheme, the host, and the path are going to be mandatory, and the port and query parameters are going to be optional. Something that is important to note, query parameters are always preceded by a question mark. Then we have the method. The method describes the action that we want to perform at the given URL. There are two main methods that we're going to be using for HTTP requests. There is the get and the post methods. Get, most of the time, allows us to receive information. So if you're reading data in a Google Sheet, you are using the get method. And post is going to allow us to send information. So if we want to send information from a form submission, we're going to be using the post HTTP method. The other methods are a little bit more rare. We have, for example, delete, put, and patch that are less common but can be used. What's very interesting with the method is they're all the time verbs, which means that they describe very clearly what we're trying to do. So when wondering which method you need to use, think of which verb would be most appropriate to the action you're trying to accomplish. Then we have the header. The header gives us a little bit more detail or context for a given request. So for example, common information that you will find in a header is going to be your location or your language preference or your device type. Every time you open a page on the internet, you're making an API request to a server, and the server is responding with the web page. So if you are browsing the internet on your computer or on your laptop, you're going to have different information or context in the header of your request. An example of a header would be accept application JSON, which tells the server that it would like the response of the HTTP request in the JSON format. Then we have the body. The body is optional and only exists for post requests. It contains the information we would like to send to the server or application. So if we take the example of form submission, then the body might contain first name Maxim, last name Paulson, and then the associated email. So this is the information that we are sending to the server. Finally, we have credentials. So the credential wasn't listed as a main part of the HTTP request because it isn't a part on its own. There are many different ways to use credentials. A credential is how we let the application know that we are allowed to make a given request. As you can imagine, if anyone could read your Google Sheets or update your Google Sheets or send messages on Slack, that would be very dangerous. So we include credentials in our HTTP requests to indicate to the server, I am authorized to make this request. Most APIs require authentication through credentials. However, there are some APIs that do not require authentication. The two most common ways to authenticate to a service are going to be through query parameters, question mark API key equals followed by the API key, or header authentication. For example, authorization, bearer, followed by the API key. Another very common way to authenticate to a service is through OAuth. Every time you click sign in with Google and the little window opens and you sign in with your Google account, this is an OAuth authentication method. Now we've seen everything that we need to send a request. Now we're going to look at how the application is going to answer with a response. There are three main components to an HTTP response: the status code, the header, and the body. The status code is a 3-digit number which will give you information on whether the request was successful or unsuccessful. The most common status codes are going to be 200, which means OK. This is the standard successful response. It means your API request was executed well, and the application is telling you, congrats, you did a good request. 401, which means unauthorized. This is usually an authentication problem. This is the application telling you, the request that you sent me does not contain the authentication information necessary to make this request. This means you need to go back and check your credentials and how you sent them, or the access that your credentials have. Another one is 404. You might remember this from the web. Not found. Usually this is a problem with the URL and means that the page or data you are looking for is not on the URL that you indicated. Finally, we have 500, which is internal server error, which indicates that the server had an error. This means it was not your fault, but the server's fault. In general, the very easy way to remember and understand these codes, if the status code starts with a 2, congrats, it was a successful HTTP request. If it starts with a 4, you made some kind of error and you need to modify your request. 500 means it was the server's error. Most of the time it just means try again later. Then, the same way we included a header in the request, the application is going to send a header in the response, giving more context or detail. So some common response headers are going to be how long is the content.